with part 2 of his building an MLOps platform from scratch. All the way from scratch. If you missed part 1, don't worry, because we'll get you all caught up right now, right here. Expect to learn a little bit about Pulumi, a little cookie cutter, maybe some Kubeflow orchestration. What else are we going to be learning? Oh yeah, I forgot about Aporia and Airflow, maybe, I can't really recall. If you're excited to learn about MLOps, you've come to the right place. There we go. Alon, welcome to the show.
Thank you.
Again, welcome back, I should say.
I've got an intro for you too.
Uh-oh. What do you mean? You're going to play that guitar behind you? Uh-oh. He brought out his guitar.
You always do the intro, so.
Let's see it. Let's see what you got. Wait, can I choose a key?
No. I'm not good with keys, yeah.
All right. Just give me what you got. I'll be happy anyway.
Thank you. Can you hear my guitar?
Oh, yeah.
Hey there, Demetrius. Thanks for hosting me today. I'm gonna build an ML platform and it's gonna be insane. Oh, yes, it will. That's it. I don't have it anymore. Yeah, that's all I got.
Bravo. I love it. I love it. That's amazing. That kind of sounds familiar, though. I feel like I've heard that song before.
All right. Hey there, Demetrius.
Hey there, Dimitri. This might sound a little bit like that one song that you may know, but it's not.
No.
All right, man. What are you going to teach us today?
Amazing. So let's get started.
Yes.
Just one side. Let me share my screen.
All right.
Okay, can you please let me know if you can see my screen?
Oh, yeah. We see it.
Amazing. So hello, everyone. Thanks for joining after all those intros. So this is the second part of the ML platform workshop. And the first thing that I want to say is that don't worry if you missed the first part, because I'm going to do a quick recap today. And you can also watch the recording on YouTube on the MLOps.community channel. And if you prefer reading, by the way, then I also released this workshop as a blog post. And it's available in Aporia's blog, so you can just check it out. In any case, the entire code of the previous session is already available in GitHub, and the code of this session will be available soon too. Cool, so let's get started. Okay, so what did we build last time? So we built a very basic ML infrastructure that solves 4 major problems. The first one is data versioning. The second one is experiments management. Then we solve packaging and model serving. And we use DVC, MLFlow, and Fast API for those problems. So I did a quick survey in the community to understand what would you like to see in the second part of the workshop. And basically the 2 top results were training orchestration and model monitoring. So this is what we're going to build today. So let's talk a little bit about what's training orchestration and what's monitoring. So training orchestration is important when your training is compute intensive or just takes a lot of time. And you can just, like when you can just train models on your local machine, then training orchestration actually becomes crucial. So solutions like Airflow and Flyte allow you to easily send your training code to a remote Kubernetes cluster and you can basically scale that cluster as necessary. Basically, training orchestration is important when your training is compute intensive. Basically, you can just send your training code to a remote Kubernetes cluster, and you can scale that cluster as necessary. And this cluster can also include, GPUs if you're doing deep learning or stuff like that. So this is the training orchestration part, and we are going to use Flyte for that. Flyte is basically a solution developed by Lyft, which is a very large company, and we'll use that for training orchestration. So let's talk a little bit about monitoring. So you work a lot on training your model, and after months of hard work, you finally get it to production. And basically now your model is in production in the wild, but it's basically exposed to drifts, right? So drifts and also other issues that might happen in production. So your model can be trained. If you, for example, you trained it 3 months ago, then it's possible that the current reality isn't actually a good, your training set 3 months ago isn't a good representative of the current reality. So this just might lead to situations where your model may completely make predictions results that might be completely meaningless. Yeah, so basically this is one area where monitoring in production comes to place. And we're going to use Aporia. And just as a disclaimer, I work in Aporia, so I'm very biased towards Aporia, but you can check out our solution as well. Okay, any questions so far, by the way? Okay. So let's talk a little bit about what we built last time. So we had basically our data scientist, which wants to start a new project, and we built a template for this data scientist. Basically, this template included code for training, code for serving, and then he could just use cookie cutter in order to clone that template and easily start a new project. So our data scientist friend clones that template, starts training and experimenting, and while he's experimenting, then all of his experiments are saved in MLFlow, which is an experiments tracking, experiments management platform. We installed this MLFlow server on top of Kubernetes, right? So basically, MLFlow used 2 databases. The first one, we called it the artifact storage, which is basically where you store all of your models, like all of your pickle files, for example, so the TensorFlow files or whatever. And the second database that MLFlow used is the model metadata database, which is basically, stores all the metrics, all the training history, all the stuff like that. So this is MLFlow. Additionally, while the data scientist is working and training his model, we also store the data sets in the DVC storage. Okay, so DVC is a platform for data versioning, and each version of the data set is committed, just like in Git, it's committed to DVC storage. And basically, that's really important because if I have an issue in production, for example, if my model monitoring system tells me that I have a model drift that happened 3 months ago, then I can easily go back 3 months ago and see what data the model was trained on and what were the hyperparameters using MLFlow. So that was the dev part. The second part, we worked on model serving using a fast API server. So the way it works is that you basically doing an HTTP request to /mymodel/predict. You give it the parameters of the model. This goes through Terrific. Just as a reminder, Terrific is basically an API gateway. Applications that are installed on Kubernetes by default are not exposed to the internet. They are entirely within the cluster. So we use Terrific in order to expose those model servers to the internet. And those model servers were written in Fast API. Any questions on the architecture so far? I'm going to pause for a few seconds.
Yep.
Okay. Awesome. So in this session, I'm going to add two technologies. As we said, we are solving the training orchestration issue. And for the training orchestration, we're going to use Flyte, which is a product created by Lyft. And I'm going to show how it works in a second. We're going to install it on top of our Kubernetes. And for model monitoring, basically, we are going to use Aporia. The way it works is that in our training phase and our serving phase, we are going to log some metrics to Aporia, and then we can use that for monitoring. Cool, so let's get started. Let me share my whole screen. Back. Okay, can you see my screen? Okay. Awesome. So I'm going to do a quick recap on the code itself as well, because it's a lot of details. There are a lot of details, so I want everyone to be aligned. So we basically splitted our platform into two parts. The first part is the infrastructure. It's the shared infrastructure. This is the place where the infrastructure that's common to all of our models is basically saved. And the second part of the platform is the model template, which data scientists can then clone and then use it to create new models. So let's go over the infra part just real quickly. So we created the Kubernetes cluster this way. We installed Terrific. All of this part is like installing the MLFlow, right? I'm not gonna dive deep into details here, but this is basically the idea. We installed MLFlow, and then we expose it with Terrific. So this is like the common infrastructure for the ML platform. And just as a reminder, we are using a tool called Pulumi, which is similar to Terraform. And this is a tool that implements a concept called infrastructure as code. So instead of instead of manually building the infrastructure and going through AWS settings and helm install and stuff like that, we write all of our infrastructure as code. The advantage of that is basically that we can just clone that code later on, duplicate into other environments, and all of our code can be code reviewed, right? It's before, in the infrastructure of as code, people could just make a change in the infrastructure, and there wasn't a good way to review that. So that's why we use Pulumi. Amazing. So this is the first part. This is the shared infrastructure part. And the second part is the model template. So the model template is basically a cookie cutter template. Cookie cutter is a tool that allows us to build templates that other people can easily clone. So this is an example of a variable that you can use. You can use variables inside file names, directories, or in the file content themselves. So if I will call my model fraud detection model, then that will appear here automatically. So we have this cookie cutter, and inside that we splitted that to two parts. The first part is the serving part, which is the fast API server. Let me show that to you. Okay, so this is a really simple fast API server that we can scale infinitely, depending on the size of our cluster. And this is basically the training code that utilizes MLFlow in order to send metrics and track experiments. So I guess this is a quick overview of what we built last time. So let me show you a quick problem with what we built last time. So I already have my ML platform here in production in this URL. And I uploaded a simple model that we built. It's the Iris model. So basically, let me show you the data set here. It's a very simple model. It's based on LightGBM. And it has 4 features. Basically, it predicts the type of the flower based on different parts, on the length and width of its different parts. So as input, it has the length of the sepal and width of the sepal and the size of the petal as well. And then it predicts what's the variety of this flower, which is a very simple model. So we actually uploaded that model using our ML platform. And just to make sure, can you see my HTTP request here? Just to make sure we don't have any other issues.
Looks good.
Okay, thank you. So this is basically the URL. I'm clicking send, and I'm giving it some parameters. This is the fast API server that is routed through Terrific and so forth. And okay, see a comment of share slides for sure. I will definitely share the slides when after this workshop. Okay, so the model actually accepts the input that we said. We click send, and that predicts the flower. So this is extremely basic, but there's one issue with that. Let's say that I pass a length of 100 here and a width of 200 here. Okay, so I got a result, right? And it doesn't matter what values I'm putting here. Okay, I think even with negative values it works. Let's see. I'm not sure. Yeah, it just like when the values aren't like in the range of your training set, then something really weird happens, right? The model just predicts because it's just like a mathematical function in the end, and this prediction is completely meaningless, right? Because if we take a look at our training data set, you can see that most of the values are between 1 to 6, I think, right? So all of those are like between 1 to 6, and suddenly we can see that our model just works if we give it a huge number like 200, which is completely irrelevant here. So this can happen not only within like values that are out of bound, but let's say that that the model was trained. Let's just open a quick example. Let's say I trained my model on like 1 to 2 centimeters, and then also 3 to 4 centimeters. Okay, so the model is really good when predicting those sizes. But then let's say that in production you suddenly see a size like that, right? It makes sense, right? So the prediction for the model might be irrelevant here. Okay, and this can be much worse. If I have something like that, then this prediction might be completely irrelevant. So usually when you're researching, you can catch some of those issues, but in production is always so messy and you have no idea what's going on with it. So this is like the real, the real place where monitoring is important. And I'm going to show you how Aporia comes into place here. So this is basically the way the platform works. You can see all of the models in production here. And this can be installed like in the Kubernetes cluster that we just created. So we just like an help shop. And let's start by adding a new model. Okay, so I can click add model. I'm going to call this iris model and some description. So I want to, to detect, to predict the flower type based on it's the length of its spark. And I can just, give it some color and an icon. And this is like the way that you add a model. And then basically there are 3 steps to integrating the model. We are going in this like ML platform that we build. We're going to, to integrate Aporia to the model template, and then automatically all models that data scientists create can just, use that monitoring already. So it's 3 steps. The first step is basically to install the package and just import that into my code. I think I've already done that. And the second step is to report the schema of the model. So this is very important because sometimes, you have, I've experienced some cases where a third-party vendor just changes, the type of some feature, for example, from numeric to string or something like that, and then your model is completely screwed up. So logging the schema of the data is extremely important. So you can specify, this is the way that you can specify it manually. But I'm gonna use just insert it from my pandas data frame. So I'm gonna open here our model templates. This is a spoiler for Flyte later on. Yes, so let's close everything here. Okay, so I've already cloned like the model template. It's called my model. I'm gonna go to the training part. Already imported the Aporia here. And now after training my model and sending it to MLFlow, I can basically log the schema of the model, right? Which features I have and what are their types. And I'm just gonna, infer that from my data set. So I have my data set here that I loaded. I'm just gonna change that to X and Y. So one thing that you need to notice here is that Y is basically, it's a NumPy array because it's just like the predictions. So we need to convert that to a data frame. So I'm going to do that. Let me see. I'm going to go to my notebook here. Okay, so yeah, so when you log your schema of the model, you can also log the version of the schema because your model might, change over time. And basically, if version 1 of your model has a feature with a string type, then maybe the second version of the model will be numeric type. So you can log basically the version of the model right here. And we're going to use the versions from MLFlow, like the run ID from MLFlow. And if you're using, by the way, MLFlow models, or like a more advanced use case of MLFlow, you can also use that. Okay, so let's just go with binary here. This is like the model type. And the next step is basically to log my training set to Aporia. And that's important basically because I want to make sure that my production data does not drift for my training data. So just a few more comments here. Right now I'm using like the cloud version, but basically you can just install that in your shared infra part. So right in this part, right? This is like the common infrastructure for our platform. So what I would do is just install Aporia's handchant right here. It's pretty simple, just like you install Terrific, you can also install Aporia. And then like all of the data is like stored privately in your cloud. So one thing to notice here is that login training set, let's do that. So we have this log training set method, and we can pass training set and the labels. So this is going to be y train to train. So one thing to notice here is that in some cases your training set might be extremely large, right? It can be terabytes or petabytes of data. By the way, if you have training sets of such size, for example in Vision, then this second part will also be very useful to you, the training orchestration part. So this thing only sends metrics, only aggregations of the training set, which are needed to then detect drift, right? Amazing. So this should basically load our training set to Aporia, and let's train our model. So let's run here virtual run train. This should train our model. If you have any questions so far, now this takes some time because it actually uploads, it uploads the model artifact to MLFlow, which is saved in the S3 bucket as mentioned earlier. So we are going to see a result in a second. In the meantime, I will also open our MLFlow that's from the previous session. So here is our MLFlow instance, and we have this experiment that we just ran, right? Yeah, and we can have the model here. It's connected to the S3 bucket that we created in Pulumi. And it looks like the training is done. So in Aporia, we should now say that the version has been received, like the first version for this model. So remember, I was like in the add model. I'm now adding my model to Aporia, so later on I can monitor it for drifts and other issues in production. So now after I've integrated my training set, the next step is basically to integrate the production, the serving part. So let's do that. This is the training. I'm gonna go to the serving part. This is the fast API server. And the idea is that for each prediction, I'm gonna log that prediction to Aporia. So this is basically, again, if you install Aporia on premise, then the data is completely saved within your cloud. So let's do that. The first thing that I want to do after loading the model here is to basically create like a reference to the model in Aporia. So let's copy its ID. We have this information here. This is like the ID of the model in Aporia, which I need to specify. And actually, it's a better practice to actually load that from like an environment variable or a thing like that. So I think I will set that environment variable and sec locally so we can test. So we have that. And we also need the version of the model that we are logging prediction to right now. So I'm gonna copy this thing here, which is the MLFlow run ID that I'm currently running. So this is like I'm making a reference to the model, and the final step is to log the prediction. So that's very simple. I can just call log prediction, and I need to give it like the sorry. So I need to provide the input to the model and the output of the model. And this is the way that you can provide the text drift. So let's do that. I can basically take that data frame that we have prepared here in the last session, pandas to dig, and convert that to the format that Aporia expects. And I also want to, so these are like the features of the model. We have the SEPA, all of those basically. And the second part is basically the prediction itself. Let's log that. Amazing. So one thing that you need, sorry. Yeah, any questions so far, by the way? Let me see in the chat.
I've got a quick question for you. You just mentioned before about it's better practice to run it with the environment, and why did you do that?
Okay,
like,
so
why is that a best practice, I guess, is my question.
Yeah, so that's a great question, actually. So some code, like so when you're doing code for production, then it's a really good practice not to have a lot of constants in your code, and basically to manage them in a centralized place, right? Because then your production code, when you have a lot of versions of your production code, it gets messy. Like your constants are really important, and you want to trace back to the state of the application at each moment. This is important not only for engineering and code. It's also important for machine learning, which is actually the reason that we are building this platform and tracking the data sets, and we are tracking the experiments, and now we are actually tracking production. Does that answer the question?
Yeah, totally.
Amazing. Okay, so we're logging our prediction here to Aporia, and one thing that we need to do to make it work is basically for each prediction we need to give it some kind of ID. The reason for that is that let's say that we have a recommendations model, right? Let's say that we are, I don't know, we have an e-commerce platform and we are, sorry. Yeah, so let's say that we have an e-commerce platform and we want to recommend other items, to when you're shopping to users. So after you make a prediction what the user is going to want to click, you have the ground truth after some time probably. Maybe he didn't click that item at all. Maybe he did click that item, which is good for the model. And maybe, he clicked another item or something like that. So by passing it here some kind of ID, basically after some time I can log the ground truth of this prediction, and this will allow me to see the performance of my model in production. I can actually have metrics like accuracy and F1 score and stuff like that, not for my training but for production, which is pretty cool. And if your F1 score suddenly drops by 50% in production, maybe there was a crisis or something like that, then you would want to get an alert and collect data and retrain your model and stuff like that. So in this case, we are not going to collect rank group, so I'm just gonna have a random ID here. Okay, so this should work. Let's try to run our model serving. I will need to set the environment variable, what we mentioned 1 second ago. So I'm gonna use the run ID that I've just trained. And the model ID that I've also just trained. This is gonna be, let's copy it from the training set, which should also be a bit more, ordered. Yeah, okay. So now I can run a local server of my model. Let's do that, watch it run cell. So this now downloads the model from MLFlow. That's why it's taking some time. It downloads the model from MLFlow, loads it, and after it's loaded, basically the HTTP server is up and running and we can make predictions. Amazing, so it's up and running. Let's make a prediction. So let's change that to localhost /predict, and we have a prediction here. So let's see if the logging to Aporia works. It worked. Okay, so we have the prediction is now received in Aporia, and basically that's how the integration looks like. As you can see, it's pretty quick, like it's very easy. Okay, so this is my model. Now so let me just recap and emphasize what our goal was. So our goal was to add a monitor. Basically, I want to get an alert when something goes wrong in production, something like that. Like my training set was trained on values from 1 to 6, but suddenly I have this huge value here and I want to easily get an alert. So before doing that, I'm gonna send some fake data, okay? So I've prepared a script here, it's called send fake data. And basically, this script creates a drift in my model, like a fake drift, so we can simulate an issue that happened in production. So let's run that. And this is now like simulating, a drift that can happen in production. And in the meantime, I'm gonna go to Aporia and define an alert for a data drift. So let's go to my new model here. And basically, there are 3 steps. The first step is to choose what I would like to monitor. In this case, it's going to be a data drift monitor. We can customize the monitor. And this is really important because models are completely different from each other, right? They are trained on different data sets. And they are, and they have different use cases and they run differently. You use different libraries. So like there's no one generic way to just detect drift. So one thing that Aporia allows here is to customize the monitor to the specific needs of the model, which is usually should be done by the data scientist that built the model. And then we have the monitoring working. So let's create a new monitor. And the first step is basically to choose what I would like to monitor. So we have like models from, I can track the amount of predictions that the model performs. Sorry. And basically, yeah, there are a lot of use cases here. I'm going to go with data drift. And I'm going to use my baseline as, as a baseline. So if I train on values from 1 to 5, for example, and suddenly someone gives me, I don't know, 2.5, which is a value that I did not train on, right? So if I trained on 1 to 1.5, and then 5 to 5.5, and suddenly someone gives me 2.5, and that's a bad case, then I can detect that. And the next step is to customize the monitor. And this is the part that models, since they are very different from each other, then I want to be able to customize it. So I'm going to monitor all of my features. This is taken from the schema that we uploaded to Aporia. And we choose to inspect the last day. Like every day, we want to inspect the last day and check if there was a drift compared, to training. And the next step, I can also choose, hour or week or something like that. And the next step is to basically customize my threshold here. So when this value is higher, then I'm going to get less alerts. And when this value is lower, then I will get more alerts. Okay, this is the threshold, for the drift that we want to have here. And this, like from my experience, it's really different between different models. So we built this tool here that actually allows you to customize the threshold here. So I can put it here, for example. And what we are seeing here is basically you can see the threshold that you want based on historical data. So in each place, I can see the drift score historically on the last day. And I can see that in here, the drift score was pretty high compared to here, for example. Okay, so that's why I want to set my threshold to be right here in this case. And I can then later change it and modify it to my needs. And to see why it's so high right here, then you can see the blue graph and the purple graph. Basically, the purple graph is the distribution of that feature in training set. And the blue graph is the distribution of that feature in production in the last day, or in the F of July. So I can see that there's a huge drift right here, right? And the predictions of the model can be meaningless if I want to fix that. Any questions so far? Okay. So let's go to the final step. And basically, this is the step where you can configure an alert. So I have, I'm going to configure a high severity alert. This is going to be a really important drift. I can configure it to get maximum 2 alerts per day, so I won't get spammed. And if I have Slack or something like that, I can just send alerts to that. I can click Save Monitor. And that's it, basically. Now my monitor is running in production, and when I have an issue with this model in production, then I will get a notification. So when building, a real ML platform, I would just add models automatically, like through an API, because you can have some basic monitors, like data drift, maybe with some constant threshold or something like that. And later on, you can customize it to your needs. So after I do have an alert, one other thing that we can have here is basically to it's basically to investigate what happened, and see what's going on in your model in production, without having you starting to get data from your S3 and stuff like that. So this is the model monitoring part. The second part that I want to discuss is training orchestration. So I'm going back here. So this was like the model monitoring step. And training orchestration, just as a reminder to what I said before, is basically an ability to run your training code in a cluster, in a remote cluster. In this case, it's going to be the cluster that we defined right here. And if you have like deep learning models, if you have a training set of terabytes of data, and so forth, you can just use that to make your training much faster. So what we're going to use is a platform called Flyte. Okay, so Flyte is a training orchestration. It's basically a workflow automation platform. That's what they call it. But I mostly think it's very useful for training orchestration. It's created by Leaf, and that's like, I have no affiliation with them or something like that, but from the platform that I've seen in some of our customers and also from my own experience, this the best one right now. So like other platforms include Airflow and Dagster, and we have some other platforms, but Flyte is really good, so you should definitely check it out. And the way it works is that you split your training code into different tasks. Sorry. And then so I can have a task for my pre-processing. I can have a task for my training code, for my post-processing and stuff like that. You can split your code into different tasks. And then you have the workflow which runs all of those tasks. So as you can see, the syntax is super simple. Let me show you an example for like one of their models here. So in this case, they've created a task for splitting the train and test datasets. They've created a task for training the model, for predicting, for evaluating the model and testing on the test set, so forth. So that's pretty cool. So we are going to install the Flyte Server on Kubernetes. And the way we are going to do that is basically using our infra, like our common infra path. So let's go to the to the infra. This is the common infrastructure. It contains the Kubernetes cluster, Traffic, Postgres, and so forth. And in this case, I've already prepared two examples. One example how you install Airflow, and one example how you install Flyte. So Airflow installation is actually much simpler than Flyte for some reason. Let's uncomment that. And so it's basically just an Helm chart installation, right? Just like we installed MLFlow, just an Helm chart installation. And then we can route the trip, we can route that to the L4 that we installed right here. So this is pretty simple. And Flyte installation, even though I think it's a really good platform, their installation is much more complicated right now. So if you go here to deployment and AWS in this case, then they have two options. One option is using Okta, which is I think like an automated tool for installing, and the second option is using manually creating things in the console. But I think the best way to do this is actually with infrastructure as code, as we mentioned before. I want all of my infrastructure to be completely, encapsulated within my infra code. So what I did here is basically to go through those steps and convert that to Pulumi code. So it's not that difficult, but in this case, it was it did take some time. So there are like permissions that I need to define here. I needed to create an alias database, just like for MLFlow. And S3 bucket, this is also similar to MLFlow. And then installing a Helm chart. And basically that's it. So I prepared that code for you to use. And it can be, it can be refactored and be like, more pretty, but this is an example of how you can install a more sophisticated training orchestration platform in your ML platform. So we have, we create a namespace here. We have some, S3 users, just like we had for MLFlow. I'm just gonna go through this real quick. We create a database for the Flyte. Sorry. And we install Flyte charts. And right now, like all the values are pretty much here. And I had to do here that they should really be separated to a different file. They have a lot of settings, so it was pretty important. And basically, that's it. So it did take me some time, but it wasn't a considerable challenge. Like, you just need to go through all of those steps and convert that to Pulumi code. Just as an example, if I wanted to create an RDS database, I would just Google Pulumi RDS database. I have the instance right here. And then I can copy the example code from right here and basically, just customize that code according to the settings here. So this is the way that you install it. And after you install Flyte Server, you have this console here, which is basically Flyte is divided into different projects. And if different projects have different environments, like development and staging and production, and you can just like send your training code to right here, and it will, scale that up within your cluster. So that's pretty cool. One thing that you will also need to do is basically to go through a training set and use, Flyte's tasks and workflows. What I've showed before, like I want to split my training pipeline into different small tasks. And then, after splitting all those tasks, I can. So let me recap on that. So why is splitting your training code to different small tasks is really good? So one reason for that is because let's say that you have pre-processing, okay? You're pre-processing your data, and then you're training your data. So you're training your data with some hyperparameters, but let's say that you want to try 5 more, sets of hyperparameters. So you don't want to, you always want to use the same pre-processing logic, right? And the way Flyte works is that you have a task for pre-processing, then you have a task for training, and the pre-processing step can be cached, okay? So if you have a data set of petabytes of data, then it will just be cached for all the, the steps afterwards. So that's a really good, strong point of Flyte that can just have, it could save you a lot of time if you are doing deep learning. One more thing that I want to show is that, let me go back to my Kubernetes cluster here. So let's say you have, usually you have 5 data scientists. All of them are training models all day. So you need a lot of compute resources, right? But then, you have some, vacation or something like that, and no one is working. And then, like, all the compute resources, all the GPUs, which are extremely expensive, all of that resources are completely wasted. So what you can do right here is to basically use autoscaling. And when you do autoscaling, basically your cluster can, when a lot of people are using it for training, then your cluster can be, maximum resources. And then when everyone is vacating, then this cluster can be extremely minimal. And just to make sure that you're not, that you're not spending money. So that's like one of the things that I love to do on top of Kubernetes, because both my training orchestration is on top of Kubernetes, and this also applies to my model serving. So let's say that in August you have a lot of users, and then in September you have a low number of users, and all of them are making predictions to the model server. then you can use Kubernetes Autoscaling to basically, load balance data and make sure that you are wasting resources in a good way. To do that, you can just Google Pulumi Kubernetes, or specifically EKS Autoscaling. Yeah, and it's pretty simple. You can just copy the code from here. You can create it's called an autoscaling group, and then your cluster is autoscaled to your needs. Yeah, so I think that is basically like what the rest of the part that I wanted to show. So monitoring and training orchestration, I think those are, let's go back to the slides. Those are like the major parts that were missing from the ML platform last time. So other things that are missing to make it really production is to make everything, authenticated HTTPS, stuff like that. And you probably would also want to split that into different environments. So you want to have a staging environment, a production environment, a dev environment, and so forth. I just want to show you how you can quickly do that. So Pulumi has a concept called stacks. Okay, so I have my, I have this infra here. This is like the shared infrastructure of my, of my platform. And I can do things like that. Pulumi stack init production, and then Pulumi stack init staging. And then the idea is that all of the resources that I defined in code, like the EKS, the RDS, the MLFlow, all of that, will be just duplicated to each environment. And that's super cool because then you can test things really the way they are. So that's also a pretty cool thing that you can do if you're actually going through building this. Yeah, I think basically that's it. And I think we have some time for questions, right?
All right, I'll start us off because I've got a big question that's been running through my head as you were going through this. But please, everyone that is out there listening, ask away, fire away at us. For me, one thing that was coming up a lot was, and especially as I've been interviewing people in the past, I don't know, month or 2 months, the idea of writing tests and making sure that you're leading with tests has been coming up so much. And I'm wondering, when you're creating this, how are you creating tests and how does that just come into the picture, or does it at all?
Amazing. So that's a really good question. Basically, I have two types of, I can think of two, maybe three types of tests. The first type of test is engineering test. It's basically to test, to test this code, to test, that this prediction, this solving logic works correctly. So this is the first, testing. This is probably the first testing that you would want to do. This is always important when you write production code. Is basically to write, unit tests for your code. And this is super. Here we have this test directory here, which is auto-generated by, by Poetry, and I can just start writing tests. So just let me give you one example for a test that I would definitely write. I would want to make sure that this prediction, logic in production works correctly. So I can write a unit test that simulates exactly this with different use cases. So what I would do is to just Google for fast API, simulate HTTP request in unit test. Yeah, and fast API has a testing framework that you can use. So you can just like make a request and make sure that the response of this request is correct. Okay, so you know what? Let's do this right now. Actually, let's just try that. We have some time, right?
Yes, let's do it. I love it.
Okay, let's do that. So I have this test my model.py here. Let's import fast API test client and copy the code right here. Sorry. So let's import the prediction function that I want to test. Actually, sorry, we need to import the fast API server, and then we can simulate requests on that server. So let's do that. Let's import application from. And there's a better way to do this, because right now I guess we're in a bit of an hurry, but there's a way to just make it look like this, which is prettier. Very simple. And now we are creating the test client of Fast API, and now we can simulate a prediction. We can simulate, an HTTP request. So we are calling /predict, and now we need to pass, the features of our models, like this thing right here. So let's see how that works. Actually, I'm not sure. So this is a really good example because I don't know how to do it right now, but let's just play and see, okay? So let's open a Python interpreter, which is really good for playing. And let's import the model head right here. Let's see if that works. No, I think I need to set it to SLC. No model name. Okay. So I need to run this Python interpreter using Poetry. Let's do that because Poetry contains all of my dependencies. Okay, and now we can finally import it, I guess. This is again taking some time because it's downloading the model from MLFlow right now. Usually in Unitest you would want to have a local model or something. Just a few seconds. Okay, so we have this. Let's now try to create this test client right here. Test client is not defined. Let's import that. And let's do this. Okay, we have our test client. Let's now try to see how we can make a fake prediction. Let's check the help of this function. Okay, so I see the first parameter is URL and the second parameter is a JSON. I can just pass like a JSON to this thing. So it's pretty simple. Let's copy our features right here. This is just one example. And then let's do /predict JSON equals features. Okay, and we have this request was successful, and we can right now we can check what was the actual response, what was the actual prediction. So to do that, I'm not sure like what to do right now, so I can just do dir, which is basically all of the properties that I have in this API call. Oh, this is really, I must say that this is super stressful to do when you're doing live coding, when you have completely no idea of what you're doing.
Dude, but this is why it's so cool. I love that you don't know and it's not polished because it shows you working it out in real time.
Thank you. So I can see that we have this JSON, which is probably the response. Let's see. This is actually a method. So I'm not sure why like this upper arrow doesn't work for me. Okay, and we have the prediction. Wow, that was pretty cool. Okay, so yeah, so let's write that down as code right now. Oh, we actually had the answer right here, but okay. So this is we are doing like a unit test for model serving. And then we want to make sure that for those parameters, the correct value is like, it's this value. So probably want to make some, some tests like that just to make sure that, so let me just show you how you can run this test. I'm not sure. Let's Google Poetry run test. I don't remember. Okay, so I think you can just use Pytest. Let's see. Let's just do that. Poetry run Pytest. Pytest is a really cool framework for writing unit tests. And it, okay, I need to be right here. So let's see. Okay, so it ran the test and we have an error. No module name my model. No module name my model. Maybe that should also. Let's see if it works right now. Okay, so this is okay. So I think that's actually working, but it's taking some time because it's downloading the model from from MLFlow, which is actually a bad practice when you're doing unit tests. You want your unit tests to run like this, really fast. But anyways, this is the way you do it. I guess this is like the first kind of test that you can do. Okay, I have some errors here, but like this is like the basic structure of how that looks. And one really cool thing that you can do here is actually to go through all of your training sets. Like I can just import. I can just like import pandas, right? And I can just load my training set or my test set if you would like. And then I can just iterate all of those rows right here and just make sure that the prediction is similar to what we had in training. So this is a pretty good test that I would definitely do if I were deploying models to production. I think it's really basic one. And if you have, I guess you are going to have also other kinds of pre-processing steps and stuff like that. You would also want to to implement unit tests for that. So that's the first part of tests that I would actually implement for machine learning models. The second part is to actually test your data. Test your data itself. Test that the schema of your data is correct. Test that that the values are in range and stuff like that. So for training, you can use I forgot the name of the library. Let's try to do that. Training data manifesting. Let's see if it's like written right here. Had it 1 second ago. I just forgot the name. Sorry. By the way, a really cool trick to search for libraries is just to write GitHub. Training data testing. I don't remember the name of the library. Pretty popular. Yeah, can't find it right now. So I would also like this is more advanced, but I will also make I would also write tests for my training data themselves, because in a large organization you have you have a lot of data engineers and you have a lot of data scientists and everything is really messy. So I really want to make sure that specific things about my data are correct. And in production, I think monitoring your model, and I know I'm a little biased, but I really truly honestly think that this is like just crucial. Like how you could serve a model without checking what's going on in production. I hope this is like a good answer to the question.
Yeah, that's awesome. And I mean, you mentioned also that it's a bad practice to have to download it from MLFlow all the time. So the remedy to that, you said, is just by having it be in local mode.
Yeah, so it really depends on the size of the model. But if you're using, let's think, if you're using small models like large GPI models and stuff like that, I would just, before running my unit test, I think I would. Okay, so there are like two approaches to how you do unit tests. Okay, and this is like a huge discussion that usually happens. One kind of unit test is when you basically, I have this function right here. This function has external dependencies, right? One of its external dependencies is model.predict. So, someone would just say, okay, so you need to fake this model, you need to make a mock. Okay, you need to basically mock that data and just make sure that this logic is correct. This is one approach to unit testing. Another approach to unit testing, this is called white box. I really check everything here. Another approach to unit testing is black box, and I think in this case I would definitely want to have my model when I do unit tests. I would definitely want to work against my model, even though it's an external dependency. And what I would do in this case, I think, is to just, import my training code, right? And I have this train function or whatever, and I can just call it right here, and then make sure that my serving code uses that model. So that works for small models, but not for, I guess, larger models like, if you have a vision model, which is really complicated, then maybe that one wouldn't be so smart thing to do. And just one final thing that you can do here is to run those tests both when you are building your serving code, but also you can run those tests when your model is already in production and you just, maybe adding more data or stuff like that. So it's useful in both cases. Yeah.
Amazing, dude. I think that's it. I'm not seeing any questions from the team in the chat. I guess you've explained everything so thoroughly. You're not leaving us with anything to ask. And now we got to do part 3. What's in it for part 3?
So that's a good question. I guess one thing that's a requirement for for models is for making this platform actually real and something that you can actually run in production is basically to create non-production environments like staging and dev and stuff like that. Scaling, like auto-scaling, I want to make sure that this platform can scale or not accordingly. I want to make sure that everything is behind authentication and everything is encrypted in HTTPS. And yeah, I think like those are some basic things that you really need to do before actually, deploying this something like that to production.
Okay. Well, that'll be in a few months. We'll have you on here and you can teach us how to do that too, huh?
Yeah, for sure.
There's a question that just came through in the chat before we finish this off. How do you review models, for example, in PR?
Oh, so that's a tough question because, when you're doing a pull request, then all you see in the model is just like your training code, and you see, you can just see some hyperparameters, and for the code reviewer, it doesn't really mean anything, right? Because just some numbers or something. So one thing that I would do when I am code reviewing, for example, if I'm leading a data science team and I want to review, a code of my data scientist, I guess the most basic thing to do is to just open the pre-processed data and in like pandas profiling or something like that. I mean, at the minimum, you would want to make sure that the data looks okay. Like you would want to look at the distributions of your features. For example, as a code reviewer, I would want to to check that if I have an edge feature, then the distribution of that feature is between 5 to 100, right? Something like that. So this is like I guess the most basic thing that I would want to check. Another thing that I want to check is basically the correctness of the code itself. So even though, I have actually a really good example for this, but even though sometimes, with training code cannot all just hyperparameters and numbers, almost all the time you do have some logic, right? You do have some Python code that's doing something, pre-processing data, something like that. So you also want to review that. And just let me share my screen again and show you a quick issue that definitely should be, can you see my screen? Hello? You appeared?
Yep, I can see it. Sorry, okay. I was on mute.
No problem. So one thing that as a code reviewer I would want to do to verify, for example, something like that. Let's say we have this Python. Let's say we have this pre-process function, right? And we have this data frame here, and logic, right? And then someone does something like that. The my feature equals something, and then he does something like that. So this is a really dangerous situation that I've seen a lot, actually. So what's happening here is that in my pre-processing code, I am adding a new feature, right? I'm adding my feature, which is a new feature, which is basically probably calculated from, from other kinds of features. But let's say that I have an exception here, right? So this feature would be none, or something like that. And then my training code could be completely, invalid. Like the output, the final model could be completely irrelevant. So this is especially dangerous if you are doing automatic training, right? If you're doing automatic training and you have an else like that, and maybe this is like doing something from a third party. And if you have something like that, then this can be, and suddenly, your third party vendor stops working, then this feature would be just null or none or something like that, because we would go to this case, to the except case right here. And then, the model can also be sometimes, I've seen, places where the model is automatically deployed to production, and then it's completely irrelevant, and it can affect, the business in the end. So it's, besides looking at the data, it's also important to look at the logic, at the code itself. So make sure that you have, what I would do actually, if I were leading a data science team right now, I would make a list of guidelines. Okay, I would make a list of guidelines, make sure that if there is a try except, then stuff like that. Okay, just common cases that you can imagine.
That's a huge insight. Thanks for that, Anne. And thanks for this session. I think we can end it here and patiently wait for session number 3.
Thank you so much. I'm looking forward to it.
All right, dude. I'll see you later. See you,
Bye-bye.
everyone. Thanks for joining
Bye,
us.
everyone. Thank you.